Hey everyone, and welcome. So you're running workloads on Azure Kubernetes Service. You know that hitting deploy on a new cluster, well, that's really just the beginning, isn't it? Today, we're going to go way beyond the default settings and talk about what it actually takes to harden your workloads and build a truly secure foundation. All right, let's dive in.
So let me just ask you, point blank, how secure is that cluster you just spun up? It's super easy to assume that the defaults are good enough for production. But the reality is, a default deployment leaves quite a few doors unlocked. Look, it gets you up and running, for sure, but a fortress it is not.
To make this all feel a bit more real, we're going to follow a pretty typical microservice on its journey. Just imagine a service that needs to grab secrets from Azure Key Vault and pull some data from Azure Storage. We're going to take it from its starting point, which is pretty vulnerable, and step by step, we'll transform it into a hardened, secure part of your application. Okay, so first up, let's take a look at the before picture. This is the state a lot of services are in, especially when you're just trying to get things working. And hey, it works, but it's often built on a foundation of some pretty risky assumptions. Okay, this slide right here, this is basically our roadmap. On the left, you see the stuff that's super common, but honestly pretty insecure. We're talking about stashing secrets in plain old config maps, having a total free-for-all where any pod can talk to any other pod, deploying images without even checking what's inside them, and giving pods way more permissions than they'll ever need. Our goal is to transform every single one of those into the secure alternatives you see on the right. And this really hits the nail on the head. Securing your cluster isn't always about fighting off some super sophisticated zero-day attack you see in the movies. So much of the time, it's just about systematically closing the doors on these well-known misconfigurations. It's about mastering the fundamentals, which is exactly what we're about to do. All right, let's get to it. Time to start building our fortress. And the very first step is to harden the workload itself. We have to control what we let into our environment, and then strictly define what it's allowed to do once it's inside.
Our first line of defense is image scanning. I mean, you wouldn't let a stranger just wander into your fortress without checking who they are, right? Same logic. Before an image even thinks about getting deployed, you need to scan it for known vulnerabilities. You'll see these called CVEs. Tools like Azure Container Registry Tasks or Microsoft Defender for Cloud can totally automate this for you, so you're not accidentally deploying known security holes into production.
Next up, we need to lock down what a pod can actually do, and that's where pod security standards are a game changer. Just think of them as a tiered path to security. Privileged is the Wild West, just avoid it. Baseline is a fantastic starting point. It shuts down the most common ways a pod can try to escape its boundaries. And then restricted is the hardened ideal, the goal we're all aiming for. The best part? You can use Azure Policy for Kubernetes to enforce these across your entire cluster, making security the default, not just an option someone might remember. So, a fortress has walls and it has gates that are controlled. Your cluster needs the exact same thing. By default, any pod can talk to any other pod. That is a massive risk. Network policies act as a firewall inside your cluster between your pods. The best practice, hands down, is to start with a policy that denies all traffic by default. Then, you explicitly, carefully, open up only the specific paths your app needs. For our microservice, it should only ever be allowed to talk to its database, not the front-end UI pod, not anything else.
So we've hardened the pod, we've controlled the traffic flowing around it, but what about when that pod needs to talk to something outside the cluster? How does our microservice securely prove who it is when it needs to access Azure Key Vault? This right here is one of the most critical pieces of modern cloud security.
Seriously, think about your own services right now. When a pod needs to get a secret from Key Vault, how does it do it? Is there a connection string or a service principal key just sitting in a config file somewhere? Because if there is, you've got a long-lived, high-value password that, if stolen, can be used from literally anywhere in the world.
And honestly, this table says it all, doesn't it? Embedding secrets is a high-risk pattern we just have to get rid of. The older way, managed identity, was a really good step in the right direction. But the gold standard today is Azure Workload Identity. It lets you grant an identity directly to a Kubernetes service account. What that means is your pod gets a short-lived, automatically rotated token to access only the specific Azure resources you've given it permission to. No more static keys, ever.
Okay, wow, we have covered a lot of ground. We've scanned our image, we've restricted our pod's permissions, locked down the network traffic, and given our microservice a secure, modern identity. And that brings us to the after picture. But all this theory is one thing, taking action is another. So let's put together a clear action plan.
Where do you actually start? It all boils down to focusing on three of the most critical changes you can make. If you do nothing else, these are the 3 immediate, high-impact improvements that are going to give you the biggest security boost right now.
All right, here it is, your action plan. Number 1, and this is your top priority, hunt down and eliminate every static secret. Replace them all with Azure Workload Identity. Second, use Azure Policy to enforce the baseline pod security standard across all your namespaces. This is a huge win that just wipes out an entire class of vulnerabilities. And third, implement a default deny network policy. Start isolating your workloads from each other. These 3 steps will fundamentally transform your cluster's security posture.
And that brings us to the end. We've seen exactly how to take a typical microservice and build a real fortress around it. The principles are straightforward, and all the tools are right there for you inside Azure. So the only real question left is this: when you look at your own environment, which one of these are you going to implement first?